In this video, I'm going to walk you through Lesson 7 of Unit C1 from Open Sci-Ed. All right, we made it to the end of the second lesson set. It's now time for a transfer task. But before we do that, we need to develop more ideas about feedback loops. So we introduced feedback loops in the last lesson, but we need to go a little deeper in this lesson about them. But we start by navigating in and thinking about who should or should not make decisions about these design solutions. And so we're really pushing towards evaluating design solutions at the end of the unit. But we just calculated that the microbeads cost a lot. It's pretty bad for the environment. So maybe it's not the best solution. And then we are going to think about feedback loops and what happens if we didn't use a solution. And that's how we brought it up in lesson 6. And so we introduced this handout called Earth's feedback loops. Now, there's two things I want to point out in this handout. The first one is, well, you're going to have to adjust the format, but that you have positive feedback loops here. And then on the second page, you've got negative feedback loops. Now, I have had teachers say this is not how they've done feedback loops in the past, but I want to point out a couple things. Number one, arrows. That shows the relationships between these two events that are happening in the feedback loop. A red arrow with a plus sign is a positive interaction or a positive relationship, and then a blue negative is a negative relationship. This, if you follow through, you will see this one is large herbivores support grasses. So you've got large herbivores, they eat large plants in an area, which clears the way and grasses grow quickly, which actually gives a lot more food for the herbivores and they fertilize them. And then we've got more food, so more herbivores, which means they eat all the large plants. So the large plants are getting smaller, they're going away. So it exacerbates the problem of the large herbivores eating the large plants. So this is a positive feedback loop. The problem gets worse and worse. Here's another example. Forest fires becoming more common. We've got increased global temperatures, which means the plants dry out. Then the forest fires are more likely, which then one, there's less plants to capture carbon dioxide, and it increases carbon dioxide and stored carbon from the trees that burns. That's from B2, the fire unit, goes into the atmosphere. And so both of those are going to increase temperatures. So the increased temperatures and fires are a positive feedback loop. It exacerbates the problem. It gets worse and worse. Now, if you look below at the negative feedback loops, you will see that, again, we have a starting position, but I want to point out two things. You got a lot of red positive and you got a lot of blue negative. But there's two things you need to notice. You've got the global temperatures decrease here and a global temperatures increase here. There's a balancing system. So this doesn't get worse and worse. A negative feedback loop basically balances itself and keeps it stable. And so then we go over here, we've got clouds and climate change, same thing. We've got global increase in temperatures. When you got evaporation of water, you have more clouds, which increases albedo, but then less light reaches the surface. We've got fewer clouds, albedo decreases. So we've got a balance here. It's more stable. Those are the big ideas. Now, I will share with you that there's a video to help you explain this if it's too much. So this comes from the materials prep section. There is video support. If you do not feel like you can explain this in the right way, we've got a video that can do it for you, or just watch it because I didn't do the greatest job and they do a much better job. And then they're going to discuss how these feedback loops are affecting the different systems, the spheres. So we've got the atmosphere and the hydrosphere, and we're bringing some earth science in here. This whole unit is very earth sciencey. And then we're going to prepare for the transfer task. Now, the transfer task is called the permafrost thaw transfer task. So they're going to take everything they've learned and they're going to put it to use in this assessment. Now, there is a positive feedback loop that they're going to need to identify as being a positive feedback loop. And they're also going to answer a few more questions. Take a look at it. I'm not linking it here because students may have access to this because I have it free online. So go in your Google Drive, find the assessment, maybe make some modifications, and you give your students plenty of time to take it. And I will say, really on-ramp them, make a level playing field, really make sure everybody understands what permafrost thaw is. There is a video here to show what it looks like. And basically, here's the gist of it. The permafrost, when it thaws because of increased temperature, it then releases more carbon dioxide into the atmosphere, which then increases temperature more, and more permafrost is going to thaw. So that's the gist of the assessment. At the end, we're going to go back and look at our driving question board because we have now reached the end of lesson set 2. We need to motivate the need to still look at the berm solution. So we go back to our driving question board, we see what we have answered, we see what we still haven't answered, add any new questions. Well, but what about the berm solution? We haven't figured if that one's a good solution yet. So let's go there next in lesson set 3. All right, let's look at the materials prep video, and good luck with lesson 7.